Is this visible? So
Yes, sir.
welcome. Okay, welcome to the second session where we need to discuss about the serial communication techniques in 8051. So there are serial ports over here by which the serial data can be transmitted or received. Okay, basically the serial transmission, in serial transmission there are two ways to perform it. One is the synchronous transmission and another is the asynchronous transmission. Okay, in synchronous transmission what happened, uh, a common clock is used for both transmitter and receiver, and in case of in case of asynchronous transmission, the synchronization is achieved only at the beginning of the transmission, and then it is maintained by the transmitter and receiver. Okay, another is in asynchronous transmission. Now synchronous transmission, to achieve this synchronization between the transmitter and receiver, it has a certain disadvantage of having the cost, the cost will be high, cost will be increased to maintain this system, which is using synchronous transmission technique. In case of asynchronous, it is relatively low. uh, for long distance, for communication purpose, it is used for asynchronous transmission control. Okay. And as well as the synchronous, it has certain advantages and disadvantages. So asynchronous transmission, there must be certain uh, start bit, stop bit along with the actual data. Okay, suppose one data is 8-bit wide. Okay, so D0 to D7 must be there, the 8 bits will be there, and first D0 will be sent, then one by one up to the D7. But before sending the D0 bit, you must give a start bit along with this data byte. So there must be some start bit which is obviously 0, and after ending of this data bytes, means after D7, one stop bit must be there, and in between there may be error checking bit which is called the parity bit. Okay, so the length of this and the total data package is called one frame. So in this frame, basically it's a complete and non-divisible group of bits which can be transmitted at a time. It contains the actual information, that is the data, as well as some extra beats to maintain the synchronization and integrity of the data, just like start beat, stop beat, parity beat. These are incorporated into this actual data bits. Okay, now there are two terms you need to familiar with. One is called the baud rate, another is the bit rate. Okay, so baud rate, what is it? It is defined as the rate at which the data is being transferred serially. That means a rate at which signal transitions occur. Okay, signal transition means frequency of signal transition. So the rate at which this frequency of signal transitions has been occurred is called the baud rate. For example, if the signal makes a transition every 5 millisecond, then the baud rate is 1 by 5 millisecond, which is equivalent to 200 baud. Okay, so 200 baud, that is called so different baud rates are available, like 300, 600, 1200, 2400, 4800, 9600, and 19200. So it is basically the multiplication of 2. In this way we can perform the baud rate and select the baud rate according to our requirement to transmit the bits serially. And another term is called the bit rate, actually bits per second. So how many bits will be transferred in 1 second, that is called the bit rate. Okay. So this baud rate and bit rates are very useful, a very major requirement in case of any serial data transmission technique. So basically to interface a microcontroller with the serial data lines, the serial data must be converted into the parallel and vice versa. Okay, so serial in, parallel out, and parallel in, serial out shift registers can be used to perform these conversions. Okay, and also the handshaking circuitry is required to synchronize the transmitter and receiver. So many devices are available which contain circuitry required to handle this serial communication. Okay, now Intel 8251 is one type of that device which can be used to connect the serial communication device, and usually it's called the USART, universal synchronous asynchronous receiver transmitter. Okay, the 80, in case of 8051, it has a built-in UART. UART, huh? It's not USART, it has UART, UART, universal asynchronous receiver transmitter. Okay, it is not used for synchronous transmission, it is used for asynchronous transmission. Okay, so the 8051 chip is capable of handling only asynchronous transmission and reception of serial data. Now 8051 has two pins, one is called the TXD, if you can remember it, TXD, which is port 3 alternative function of port 3, like 3.1 that is used for TXD, and then the 3.0 P 3.0 here in this case P 3.0 that is for RxD, and P 3.1 that is for TXD. This is for receiving purpose, this is for transmitting purpose. So port 3 can be used to perform these two functions. Now the UART hardware is more commonly referred as serial port. Okay, this hardware it implemented into this IC, so it is referred as serial port. Uh, Other features are like it supports full duplex serial communication, that is transmission and reception of data is simultaneously possible. Another is transmit and receive buffer registers along with transmitting and receiving shift registers. And and logic for generating the timing signal, that is the clock signal, and the status bit showing the data byte has been sent, a status bit, and another status bit to indicate that the data byte has been received. Okay, so for serial port in of the 8051 is controlled by two registers. One is called the S buffer register, means the SBUF, serial data buffer register, and another is called SCON register, which is called the serial port control register. Okay, so using these two registers, the serial port must be controlled. Now serial data buffer, which is called SBUF register, it's an 8-bit register used for the serial data transmission and reception. Now a data byte must be written to S buffer register for transmission through the transmitter line, and the same way it also holds a byte of data received from the received data line, RxD line. Now, though there is only one name for this register is buff, there are actually two separate physical registers are there, which is called, one is transmit buffer, another is receive buffer. Okay, now these two registers are differentiated by a microcontroller as per the operation being performed within them. So when S buffer is read, the receive buffer is accessed, and while transmitting, transmit buffer is accessed. For example, like we can write it as move a comma. If you have pen and paper with you, we can write it, move a comma S buff, move a comma S buff. Okay, so this will read receive data from receive S buffer register. Okay, so receiver buffer will receive data from RxD line, while an other instruction, if it can be written as move S buff comma A, will this will write data to transmit S buffer register, which is basically a transmitter buffer, and the data from this transmitter buffer will be transmitted through the TXD line. Okay, so that is the function of S buffer this register, serial buffer register. Another register which is called the serial control register, in short it's called SCON. So this SCON register, actually it is the control and status register, programmed to configure bits contained in one serial word, baud rate, or the synchronization clock source. Okay, now it also contains status bits that indicate whether the data is transmitted completely and any new data is received. Okay, so there is a configuration of a SCON register here. It is given in this way. So SCON basically serial port control register. It's a bit addressable register like SCON 0, SCON point 0, SCON point 1, SCON point 2 up to 7.7. Okay, it is bit addressable. So basically SCON register, it has these bits like from the this is D0 bit, this is D0 bit, this is D7 bit. Now D7 and D6 bits are used to select the different modes. Okay, serial port mode bits 0 or and 1. So if both are 0 0, then mode 0 will be selected. So in 8051 microcontroller, it has 4 modes: mode 0, mode 1, mode 2, mode 3 for serial data transmission technique, communication purpose. So if both are SM0 and SM1, both are 0 0, it is in mode 0, which is called the shift register, which acts as a shift register mode, where baud rate is fixed, that is the crystal oscillator frequency divided by 12, because the 12 is the oscillator frequency, 12 megahertz. Okay, and if these twos are 0 and 1, it is in mode 1, which is used as just 8-bit UART mode, but the baud rate can is variable, and that can be performed by the timer clock, which is again performed. The T mode and T-con registers are available, bit formats are available. Here the clock signal of timer define what will be the baud rate of this one. Okay, so it is related to the timer circuit, so that's why it can be variable. And SM0, SM1, if both are 1 0, then it is in mode 2, 7, 9-bit UART. It's called the 9-bit UART. And one by either the baud rate will be crystal oscillator frequency by 32 or crystal oscillator frequency by 64. Okay, it depends on the requirement. If both are 1 1, then it is in mode 3, which can be used as same as 9-bit UART mode, but the baud rate is variable. So both these two, mode 2 and mode 3, actually this mode 1 and mode 3 will be actually the same type, only the difference is here. Then here it is used as 8-bit UART, here it is used as 9-bit UART. The extra bit will be used for parity bit checking. Okay, so the next SM2, that bit, serial port mode bits 2, it is actually enables multiprocessor feature in mode 2 and mode 3. So basically mode 2 and mode 3, these two modes are used for multiprocessor mode. Mode 2 or mode 3, in this case SM2 is equivalent to 1. Now RI, that is the receiver interrupt, receiver interrupt, whatever, that will be 1 when the 9th number bit will be received by the system, and it will be treated as 1. In case of mode 1, if SM2 equals to 1, then receiver interrupt will be 1 when the stop bit received as 1. Okay, and if it is in mode 0, so SM2 is kept 0, that is not used anywhere. Then next is the receiver enable bit. Next bit is called receiver enable bit. If it is 1, it enables the receiver. If it is 0, then it is disable the receiver. Then TB8 or RB8, that is for bit 8, that is 9th number bit is transmitted to this bit. Now in mode 2 and mode 3, it holds a 9th number programmable bit that is to be transmitted, and in mode 1 and mode 0 it is not used. Okay, and that is the difference. So this mode 3 and actually mode 1, both are the same type of operation, only the difference is here the 9th number bit is to be transmitted to this TV8. Okay. And RB8, this is for receiving purpose. If 9th number bit is received, it is given to the uh, in this particular bit. In mode 1 it receives the stop bit, and in mode 0 it is not used. Okay, so next is the TI and RI. TI means the transmit interrupt, so it will be 1 to if one complete operation is performed, that means one data is being transmitted, then automatically in this interrupt will be generated. Okay, and in the same way, the receive, after receiving one's complete data byte, the corresponding interrupt will be generated. Receive interrupt will be generated. Okay, and both of these, this TI and RI can be cleared by using the software to transmit or to receive the data byte, new data byte again. So that is the serial SCON SFR register bit format. So different modes, now we will discuss about the different modes are available in case of serial transmission, serial communication purpose. The first mode is called the mode 0, which is acts as an 8-bit shift register mode, 8-bit shift register mode. Now both in this mode, in mode 0, what happened, data are transmitted and received through the same pin, that is RxD pin. Okay, and TXD pin that is available, RxD pin means the receiver data pin. Okay, and the TXD pin, which is called the transmitter transmit data pin, it is used, this pin actually outputs the shift clock signal. Okay, and this is used to synchronize data transmission and reception purpose, TXD line. So both data receiving or transmitting purpose, RxD line is used. It can perform both functions. Only the clock signal which is shifted to this TXD line. Okay, it is used to synchronize the clock signal with the transmitter and the receiver. And on transmit, the least significant bit, that is the LSB bit, which is D0, it is sent or received first. Okay, now in case of transmission, what happened? Transmission begins by any instruction that uses is serial buffer register as a destination register, regardless of the state of TI flag. Okay, TI flag. TI flag means transmit interrupt flag. So these are basically transmit interrupt flag and receive interrupt flag. This TI and RI. TI and RI, these are receive interrupt flag and transmit interrupt flag. Okay. So regardless of this TI transmit flag status, transmission begins, and when the transmission is completed, all 8 bits have been sent, then the TI bit of the SCON register, this will be set automatically. Okay, it generates the interrupt signal automatically. And in case of reception purpose, what happened? Data reception basically used by the RxD pin begins when the conditions are such as RN equals to 1 and receiver enable. If RN is 1 and and RI is 0, if these two conditions met, this is 1, this bit will be 1 and this bit will be 0, at that time receiver section will be enabled. And the condition RI equals to 0 is exceptional for mode 0. Okay, because all other modes are enabled to receive when REN equals to 1, irrespective of this RI. So because in mode 0 only we can control when the reception can occur. When all the 8 bits are received, this RI bit of this SCON register is automatically set to show that one byte is already received, and also prevents reception of any character uncleared by the program. Okay, so during this transmission, what happened? Uh, Here is the clock signals, timing signals. So during this transmission, the data is shifted out from RxD pin. Okay, and the data changes on trailing edge of the S6P2. This is S6P1. This, that is S6P2. Okay, so it is data is S6P2 state, and TI flag, corresponding TI flag is set after transmission of 8 bits. Now, during the reception, what happened? The data is sampled on this trailing edge of the S5P2 here in this position. Okay, so what is S3P1, S6P1, S5P2? Okay, we have certain confusion. So basically, in case of all of you know about the instruction cycle, machine cycle, T states. All of you have heard about these terms in 8085 microprocessor. Now in 8051 microcontroller, what happened? Total so 12 uh, cycles are total 12 cycles are available for uh, one complete cycle. Okay, one complete instruction cycle. It is divided into in such way one machine cycle, sorry, not instruction cycle, one machine cycle, and this machine cycle basically use two clock signals. Okay, phase 1, phase 2, that is P1, P2. Okay, so every signal is divided into two clock signals. So if there is 12 clock cycles, so and each clock cycle has two phase, so that means there must be total 6 clock cycles for one complete machine cycle. Okay, so 6 clock cycle means it is divided into two parts, so total is 12 clock cycle for one machine cycle. And is state 1 means the S1, S2, S3, S4, S5, S6. Okay, so these are total 6 machine cycles are there. 6 machine cycles are there. Now in each machine cycle there are 2 cycles, phase 1, phase 2, means P1, P2. Suppose first state is S0. Okay, so the falling edge of one pulse to the rising edge is called one cycle, and another is the next one. So 2 cycle will be present in S0 state. Then S1 state, another 2 states will be there, P1 and P2. Then S2 state, so S0 has two states, one is S0P1, S0P2. Then for the next one is S1P0 and S1, sorry, S1P1 and S1P2. In this way, S2P1, S2P2, then S3P1, S3P2. So every state, this S means state. So for every state of clock cycle, it has 2 substate, P1, P2. Okay, so these are actually S3 has 2 state, S3P1, S3P2, S6P1, S6P2. So in this way, maximum 6 states are available, where a state is divided into 2 clock pulse, subdivision of clock pulse. So these are referred by this state. Okay. In case of mode 1, what happened? So that is for mode 0, and basically in actually mode 0 only perform the synchronous transmission in this case. Okay, only mode 0 is available for synchronous transmission. Other modes like mode 1, mode 2, mode 3, these are available for asynchronous transmission. Okay, now why this mode 0 was called so-called 8-bit shift register? Because it has two registers here in this to process this serial buffer. One shift register is called uh, the serial input parallel output SIPO register, serial input parallel output, and another is called parallel input serial output PISO register. Okay, so these SIPO and PISO registers are incorporated into the S buffer register, okay, to process this. In case of mode 1, what happened? It's a standard 8-bit UART mode. Now UART is designed mainly for this mode, and frame format of this mode is compatible with every communication port of every PC. And now this mode actually transmits 10 bits through TXD line and receives through RxD pin. Okay, and it receives actually a start bit always 0, which is obviously a logic low level signal, 0, 8 bit 8 data bits LSB first, and stop bit, which is always 1, which is high level signal. Okay, now in case of transmission, what happened? The data here in this case, this is for transmission section, transmission. If you have any queries, Shomik, you can ask me after delivering my lecture. Okay, I will ask you, then you can ask me anything. Huh? So first, let me finish my lecture. Shomik Das. Okay, you have raised your hand. If you have any queries, wait until I have finished my discussion. So actually data transmission in case of this technique begins by writing data to the serial buffer register here first, in this position, serial buffer register. Then the start bit and stop bits are added by hardware to form a 10-bit frame. In this way, start bit, then 8-bit data is there, and one stop bit. So total is 8-bit, sorry, 10-bit. 8-bit is here, 9 and 10. So total 10 bits is formed by the hardware method, which is incorporated inside this IC. Then this 10-bit parallel to serial conversion is performed, and 1 bit LSB first at a time is transmitted through the TXD pin. Okay, over here in this pin, parallel to serial. And once this once once the complete frame is transmitted, the TI flag is set automatically by the serial port hardware to indicate the end of the data transmission. Okay, now we need to monitor the TI flag, which is the transmitter interrupt flag, to confirm that the serial buffer register is not overloaded. And if the TI flag is set, it implies that the last character transmission is completed, and now serial buffer is empty. Serial buffer is empty. Okay, and a new byte can be written to it to start the next transmission. And if a new byte is written to the S buffer before TI is 1 or TI is high, the untransmitted part of the previous byte will be lost. So it should be noted that the microcontroller sets the TI flag when it completes the byte transfer, whereas it must be cleared by the programmer after the next byte is loaded into the serial buffer. Okay, and what happened in reception? The reception begins when REN receiver enable REN equals to 1, and high to low transition of start bit is detected on the RxD pin. Okay, so here this is the start bit, high to low. If it detects by the receiver. That means the starting point is here and it is received by the receiver. One by one the bit will be received. Okay, so here basically RI is used, and the receive byte is loaded into the serial buffer register. The start and stop bits are separated by your hardware. Once completed, the frame which is received, and stop bit into the RB8. Okay, RB8 is there in ISCON register, which is in bit 2. So if RI equals to 0 only, in that case it is showing that the previous data byte is read by the program. Now either SM2 equals to 0, SM2 equals to 0, or stop bit equals to 1. Normally SM2 equals to 0 and character will be accepted irrespective of the status of the stop bit. Okay, now a programmer, a end user, you or me, can check RB8 to ensure that the stop bit is correct if required. Okay, and if these two conditions means RI equals to 0 and SM2 equals to 0 or stop bit equals to 1, if these two conditions are not met, okay, then the received character is ignored and RI is not set, and the receiver circuit waits for the next start bit, for the next new data transmission technique. Okay, so that is in mode 1. In mode 2, it is a 9-bit EWORD which is used in multiprocessor mode. Basically mode 2 is used in multiprocessor mode. Multiprocessor communication purpose it is used. So it transmits actually 11 bits through the TXD pin and receives through the RXD pin. In this way, a start bit here, a start bit, this 8 bit, this parity bit, and this stop bit. How much? So 8, 9, 10, 11. Total 11 bits has to be sent or has to be received. Okay, so total 11 bits to the TXD pin or RXD pin can be received. Now in case of transmission, when it is transmitting 8 bits data bits are loaded into the S buffer, the ninth number bit is the value of the TB8 bit in the SCON register. The programmer can set or clear this bit, the start, stop, and TB8. That means this one, ninth number bit means in this case for transmission purpose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This ninth number bit goes to the TB8 bit. Okay, into the SCON register bit format. Then the 11-bit parallel to serial conversion is performed, and 1 bit at a time is transmitted through the TXD pin. Now, once the complete once frame is being transmitted, the TI flag is automatically set by the serial port hardware to indicate the end of data transmission. In the same way, reception purpose, you must receiver enable REN equals to 1, REN equals to 1, and high to low transition will be there. So if it detects high to low, that means it's a start bit, then this will be operated in this way, and it must be the received 8-bit data which loaded into the SBUF register, SBuffer register actually. The start and stop bits are separated by the EWORD hardware once the complete frame is received, and 9 number bit obviously it goes into the RB8 of section means ISCON register. Okay, so that is in multiprocessor system. And also, so for mode 3, actually this mode is exactly the same with the mode 2, except that the baud rate is variable. Okay, in mode 2 what happened, it is fixed, baud rate was fixed, that is 1 by if means oscillator frequency by 32 or divided by 64, but here only the baud rate is variable, which can be varied by the with the help of the timer circuit. Okay, it is determined using the timer 1 overflow rate as in mode 1, that is also in variable baud rate. Okay. So these are the different modes available for serial communication purpose. Okay, and that's all for today. So if you have any confusion, any queries, any question, you can ask me. Okay, Shomik Das, can you hear me? Shomik, do you have any queries? Anyone? Do you have any queries, any doubts regarding the serial communication techniques? Do you have any queries, any doubts?
No, sir.
Okay, so the theory portion of 8051 microcontroller has been finished. So next day we will discuss about the RISC processor and then ARM processor. So I need next 2 weeks to end of my syllabus. Okay, so only RISC processor and ARM processor is pending. Okay, these 2 topics are pending. So if you have any queries, you can ask me. Otherwise, I will end my meeting. So do you have any queries? Anyone?
No.
Okay, so thank you all. I will end my meeting. Thanks.